Hi everyone, I'm Won Lee. Today, the topic is sum of squares, SS, and degrees of freedom corresponding to sum of squares. Sum of squares is very important concept in statistical analysis method. I think I'm going to explain sum of squares easily for you to understand. Okay, let's see what sum of squares is. All right, here. The sum of squares is also referred to as variation, and it can be understood as the sum of squared deviations. You know deviations, right? Let us express samples obtained for one-way ANOVA using obtained values like this. As you saw it, this table, obtained values here y11, y12, y1n, y21, 22, y2n, yk1, k2, ykn, and sample means here. Okay, samples of observed values from k populations. Population is what? Here, treatment. K different levels of treatment. One A ANOVA model is like this. I introduced it before. Y ij equal to mu plus, what is mu? Mu is, there are k population groups. It's mean mu1, mu2, mu k, but the total mean is grand mean, mu. Mu plus alpha I plus epsilon ij. Assumption is same. When the sample values have actually been obtained like this, okay, the equation corresponding to the above model is what? Small yij. This is a random variable. This is a real value. Mu, what is mu? Grand mean, total mean. So mean of all the samples, right? Y double bar, plus what is alpha I? Alpha I is I's treatment effect. So alpha I is for ith samples, y bar minus y double bar. Here, y double bar. Y double bar is mean of all the samples, okay? Plus, here, yij minus yi bar. Okay, we left it. But in order to make equal both sides, yij equal to y double bar plus yi bar minus y double bar, okay? Then for equality, yij come here and yi bar, okay, is cancelled out. So yi bar equal to yij equal to yij. So equality holds. Okay, so this is for error, right? Epsilon ij will be realized as yij minus yi bar. Understand that? In order to make it equal sign. Here, y double bar is yi bar plus y1 bar plus y2 bar plus yk bar divided by k. That is a total sample mean. I said the sample size are equal, so we can, calculate like this. Corresponds to the overall mean, grand mean mu, and yi bar minus y double bar corresponds to alpha I. Alpha I is what? Mu I minus mu. Mu I is yi bar, and mu is y double bar. Okay, so in other words, it is estimate of mu. This one, yi bar minus y double bar, is estimate of alpha I. Understand that? Regarding the error epsilon ij, they can only be obtained as like this to make this formula equal. Okay, this yij minus yi bar is observed realized value of a random variable eta epsilon ij. This is referred to as residual. Different terminology, different naming. Residual is what? Y here, y11 minus y1 bar, y12 minus y1 bar, y1n minus yi bar. For here, y21 minus y2 bar, something like that. Okay? So those values called residuals. Let's transform the above equation into, just to move this term to left, yij minus y double bar equal to yi bar minus y double bar plus yij minus yi bar. And then scale both sides and sum them up. Scale both sides and sum them up, then like this. Of course, plus 2 summation y I bar minus y double bar cross product term yij minus yi bar. Okay, 2 times. Fortunately, this gonna be 0. If you want, you can calculate why this term is 0. So here, no subscript j. So n times this summation, right? You know that, I think. Otherwise, you will be in trouble. If you think it is very difficult why this one is n times the summation, then I said you are in trouble. And the same thing here. Okay, next. I rewrite the previous formula, this one, like that. Okay, to explain some more. Then we call this term is treatment sum of squares. Treatment sum of squares. Okay, SS subscript T. This one is, what is this? Residual. So residual sum of squares. But instead of R, we use SSE, error sum of square, something like that. Okay, what is this? Total sum of squares, SST. This is SST. Okay, so SST equal, in this one-way ANOVA, SST plus SSE, sum of squares. These are, we say, relation of sum of squares. They are degrees of freedom. What is the degrees of freedom? This one. How many terms here? K many terms. But degrees of freedom is K minus 1. Because you know that, maybe, Y1 bar, Y double bar, Y K bar, Y double bar, K many terms. But if you have K minus 1 Y I bar, then the last one will be automatically decided because Y double bar here. And how many degrees of freedom here? Okay, see here. This one is residual. Okay, these are residual. How many degrees of freedom here? N minus 1. How many? N minus 1. How many? N minus 1. They are K n minus 1 degrees of freedom. So degrees of freedom gonna be K times n minus 1. How about this? They are sum of squares. They are Kn many Yij minus Y double bar, right? But Y double bar is mean of Yij's. So Kn minus 1 degrees of freedom. Degrees of freedom, total degrees of freedom, Kn minus 1 is degrees of freedom treatment, degrees of freedom's residuals. Okay? So there exists relation of degrees of freedoms. Let's see here. Okay, the sum of squares of residual, which are the realized values of the errors, this one. Examining the degrees of freedom for each sum of squares, we find that degrees of freedom also relate like the sum of squares. sum of squares. Okay? Get it? It is not difficult anyway, I think, but I think it my explanation is easy to understand. I think so. Okay, that's it today. Thank you. Bye.